Hello, today we are revisiting circumference and arc length. Now, we have worked with the arc length formula before, and we have seen them written 3 different ways, and you're welcome to use whichever one you're comfortable with. And again, you must memorize the formula that you're comfortable with because this will not be provided on the SOL, and the formula will not be provided on any of our assessments. And also as a refresher, the units for arc length are in centimeters, inches, feet, miles, etc. Those are called linear units, something you can measure with a ruler or a tape measure. But the units are never in degrees. That is for the measure of an arc, and we are dealing with the length of an arc. So to start, we have a problem for you to do, and you are starting over here on you try 1. And you're going to use one of the formulas above. Find the length of the arc that has a central angle of 25 degrees in a circle with a radius of 5 centimeters. Please pause the video here to complete You Try 1. Here's the solution to You Try 1. Your answer may be either of the answers in the box. It can either be 25 over 36 pi centimeters, or you could have worked that entire value out in your calculator and got 2.1816 centimeters. So either answer is good, and be sure that you have units. Moving on to example 1. If you had any problems with You Try 1, please pause the video here so you can make any corrections to your paper. Example 1. Now in this example it's a little bit different because the length has been given to us. We already have the length. We've been given the central angle is 72 degrees, and what we're trying to find is the radius of the circle. So I'm going to go ahead and I'm going to start by writing down the formula that I'm going to use, and the arc length is going to be that central angle divided by 360 times 2 times the radius times pi. So from here I'm going to input everything that I know. First of all, I know this number right here, 18 over 5 pi, is the length of the arc. So that is going to go in place of the length. 18 over 5 times pi. That is going to be equal to the angle over 360, and I need an angle. So let's look and see, do I have an angle? The central angle is 72. So that's going to go in place of my angle. So that's the 72 is going to go on top of my 360. Then I'm going to multiply by 2, and then I'm going to multiply by the radius. However, the radius is what I'm trying to find. So I'm going to call the radius x. So I'm going to input an x, and then again, pi is part of my formula. So that's your first step, is just enter all of your information into the formula for arc length. Now, once we have done that, we need to get x by itself. Now, I hope you notice there's something the same on both sides of the equation, and that's that pesky little pi. So what we're going to do first is we are going to divide both sides by pi. So I'm going to divide by pi over here, and I'm going to divide by pi over here. And then what's nice is pi divided by pi is a silly version of the number 1, and I don't need to have it. And this pi divided by pi is a silly version of the number 1, and again, I don't need to have that either. So on this side, I am simply left with 18 over 5. On the other side, I'm left with 72 over 360 times 2 times x. And from here, there are many different ways that you can solve this. One of these would be you could cross multiply if you wanted to. One of them is to do this step by step, but there's many different ways. I just had to choose a way. I'm going to go ahead and write what I did right here. I forgot to do that. Divide by pi. So what I'm going to do next is I'm going to go ahead and I'm going to take this and I'm going to multiply both sides by 360. I have this 360 down here on the bottom. right here. So I'm going to go ahead and multiply both sides by 360. So I'm just going to write that down. Multiply both sides by 360. So when I multiply both sides by 360, I'm basically going to have my 18 over 5 is going to be times 360. And then when I multiply by 360 on the other side, I'm just going to end up with this. So what I'm going to do right now is I'm going to rewrite that. So I have 18 over 5 times 360 is going to be equal to 72 times 2 times x. Now from here, I'm going to use my calculator and go ahead and work out what those values are. So the first thing that I'm going to do is I'm going to multiply 18 times 360. So grabbing my calculator, 18 times 360. And I get 6,480. So this is 6,480 divided by 5 still. And then over here, I'm going to simplify this. I have 72 times 2 times x. So in my calculator, I'm going to work out 72 times 2. So to simplify, 72 times 2 is the same as 144. So over on the right side of the equation, I have 144x. Now at this point, I'm going to go ahead and simplify this fraction because I think 5 will divide evenly into this number because the last digit is a 0. So I'm going to take 6,480 and divide by 5. And that gives me 1,296. So I replace that, and that's equal to 144x. And again, I'm trying to get x all the way by itself. So from here, I need to divide both sides by 144. And that's going to give me what x is. I have no idea what that is, so I'm going to need to use my calculator again. And I'm going to take 1,296, and I'm going to divide that by 144. And that gives me 9. So I replace the 1,296 with a 9, and x is equal to 9. So let's go ahead and talk about what this actually is. I'm going to go back and read the question. Now in the question, it says, what is the radius of the circle? So that means this 9 is the radius of the circle. So what I'm doing now is I'm just going to write that out. Radius is 9, and I need some units on this. The units in this one will be in inches, and I found that right here in my cloud. So the radius is 9 inches. At this point, if you turn your paper over, there's a problem for you to try. So you may want to pause the video here on this screen so that you can see what we did to solve this problem, but I would like you to turn your paper over right now and complete You Try 2. So please pause the video here. Really, pause the video, please. Here is the solution to You Try 2. Now, if you did not get that the radius was 80 inches, please pause the video here, go through the steps because the steps are all written out, and figure out where you went wrong. So again, please pause the video if your answer is not correct. Moving on to example 2. For example 2, we've been given the length of the arc, so we're used to that at that point. That's what we started with in our last example. However, in this case, we were given what the radius was, and what we're trying to find is the measure of the arc's central angle. So we're doing the same basic thing, except we're finding an angle instead of a radius. So I start by writing down the formula for arc length. Now, when I've been given the radius, what I can do is start with the diameter. And personally, I prefer, but it's up to you, the formula where it's angle over 360 times the diameter times pi. So I'm going to go ahead and use that formula once I know the radius. So before I get started with plugging things in, if I know the radius is 17, that means the diameter is going to be 2 times that, and 2 times 17 is 34 inches. So that's what I'm going to use. So start plugging things in. We start with the 17 over 4 pi is our length. So I'm going to plug that right in for my L. And next, I don't know my angle in this case, so I'm going to write an X in place of the angle. Then I have a diameter, which I know is 34. So I'm going to plug that in for my diameter. And I still have a pi. So at this point, our basic first step is exactly the same. Divide both sides by pi. So when I divide over here by pi, and I divide over here by pi, I have a silly version of the number 1, which I don't need to write, and a silly version of the number 1 that I don't need to write. So I'm left with 17 over 4 on the left side of the equation. And on the right side of the equation, I have x over 360 times 34. And again, the next step that we did in our previous example was multiply both sides by 360. So I'm going to go ahead and do that as well. So I'm going to have 17 over 4, and I'm going to multiply that by 360. And that's going to be equal to x times 34. You can also write that as 34x. So at this point, I'm going to pick up my calculator, and I'm going to figure out what 17 divided by 4 times 360 is. So again, 17 divided by 4 times 360, put that in my calculator. So 17 divided by 4, that's 4.25, and I'm going to multiply that times 360. And that gives me 1,530. So 1,530 is equal to 34 times x. Now, finally, to get x by itself, I'm going to divide both sides by the 34 so that I can get x completely alone. So, using my calculator, I'm going to take the 1,530, and divide by 34, and that's going to give me 45. So, 45 is equal to x. Now I need to be sure I put some units on here for whatever I was answering the question for. And the question was, let's see if I can find the question again. What is the measure of the arc's central angle? So that means we can write that out. The central angle is 45, and my units on my angles should be degrees. And there's my answer. So at this point, you are on to you try 3. Now again, you may want to pause the video right here so that you can do you try 3 while looking at the example already completed. But regardless, I need you to do you try 3 right now. So please pause the video to complete you try 3. So for 1 second. Sorry about that. Here is our solution to you try 3. Please pause the video here if you did not get 112.5. And if you did get 112.5 degrees, then you are finished with your video lesson. I hope you have a wonderful evening, and we'll see you in class.